Black holes are the most mysterious and powerful objects in the universe, regions of space where gravity is so strong that nothing, not even light, can escape. But what happens when two black holes collide? The result is one of the most violent and energetic events in the cosmos. A cataclysm so intense that it warps the very fabric of space-time. These cosmic collisions don't happen often, but when they do, they unleash gravitational waves, ripples that stretch and squeeze space itself, traveling across the universe at the speed of light. First predicted by Albert Einstein and later detected by LIGO and Virgo observatories, these waves provide a direct way for scientists to study black hole mergers in action. A black hole collision is not just an astronomical spectacle, it's a window into the deepest secrets of physics. These events help us understand gravity, the nature of black holes, and even the fundamental structure of the universe. But before the final earth-shattering merger, black holes engage in a deadly spiral dance, drawing closer in a process that can take millions of years. The lead-up spiral of doom. Black hole collisions don't happen instantly. Instead, they begin with a slow but inevitable dance, one that can last for millions or even billions of years. When two black holes form in close proximity or when galaxies merge, their gravitational pull gradually draws them toward each other, setting the stage for an ultimate cosmic showdown. As the two black holes orbit each other, they lose energy by emitting gravitational waves, ripples in space-time that carry energy away from the system. This loss of energy causes the black holes to spiral inward, moving closer and closer at ever-increasing speeds. Over time, this spiral tightens, and the two black holes begin orbiting at a fraction of the speed of light, generating even more powerful gravitational waves in the process. During this final phase, known as the in-spiral stage, the black holes complete multiple orbits in just fractions of a second before finally reaching the moment of impact. By this point, their individual event horizons, the invisible boundaries beyond which nothing can escape, begin to merge, signaling the final approach to one of the most violent moments in the universe. The collision, the most violent event in the universe. As the two black holes spiral closer, their immense gravitational pull distorts space-time itself, stretching and twisting it in ways that defy human intuition. In the final milliseconds before the collision, they are orbiting each other at nearly the speed of light, generating an unimaginable amount of energy. Then, at the moment of impact, the two event horizons merge, forming a single, larger black hole in an event so powerful that it momentarily outshines entire galaxies in gravitational energy. Unlike an explosion that sends matter flying outward, a black hole collision is a purely gravitational event. There is no bright flash of light, only the violent warping of space-time. This release of energy is so extreme that for a brief moment the power output of the merger can exceed that of all the stars in the observable universe combined. The newly formed black hole is not instantly stable. It undergoes a process called ring-down, where it wobbles and radiates away excess energy in the form of gravitational waves until it settles into a final shape. This newly merged black hole is heavier than either of the original ones, but not as massive as their combined total. Some of the mass is converted into pure gravitational energy sent rippling across the cosmos. While this might seem like the end of the story, the effects of the collision are felt across the universe. The gravitational waves generated by these events travel billions of light years, carrying with them the echoes of a cataclysmic event that reshaped the fabric of reality. Gravitational waves ripples through space-time. When two black holes collide, they don't just merge into a single larger black hole, they shake the very fabric of the universe itself. The immense energy released in the collision sends out powerful gravitational waves, ripples in space-time that travel at the speed of light, stretching and squeezing everything they pass through. Albert Einstein first predicted the existence of gravitational waves in his general theory of relativity over a century ago. However, it wasn't until 2015 that scientists at LIGO, Laser Interferometer Gravitational Wave Observatory, made the first ever direct detection of these waves, proving that space-time itself can ripple like the surface of a pond. Gravitational waves carry pure information about the black hole collision, allowing scientists to listen to these cosmic events even though they produce no light. Unlike electromagnetic waves, which can be blocked by dust and gas, gravitational waves pass through everything, making them one of the most powerful tools for studying the universe's most extreme objects. These waves provide a unique fingerprint of black hole mergers, revealing details about their masses, spins, and the precise moment of collision. With each new detection, we gain deeper insights into how black holes behave, how they grow, and even how galaxies evolve over time. But what happens after the violent merger? The newly formed black hole doesn't just sit quietly, it undergoes a dramatic transformation, shaping the cosmic environment around it in ways that scientists are still trying to understand. After the colossal merger, the two black holes become one larger, more powerful black hole. But the chaos doesn't end instantly. The newly formed black hole is in an unstable state, wobbling and vibrating as it releases the last remnants of gravitational energy in a process known as ring-down. These final gravitational waves ripple outward, signaling that the black hole is settling into a stable form. Despite losing some mass as energy during the merger, the resulting black hole is far more massive and powerful than either of its predecessors. In many cases, these collisions contribute to the formation of supermassive black holes, the enormous behemoths found at the centers of galaxies, which can be millions or even billions of times the mass of the Sun. In some scenarios, if the black hole merger happens within a galaxy filled with gas and dust, the newly formed black hole may launch powerful jets of energy, heating surrounding matter and influencing the birth of new stars. Some scientists believe that these mergers could play a role in shaping the structure of galaxies themselves, helping determine their size and evolution. Interestingly, if the black holes were rotating before merging, the resulting black hole could receive a powerful kick, launching it across space at extreme speeds. Some black holes may even be ejected from their home galaxies entirely, doomed to drift through the void alone. While the merger marks the end of two separate black holes, it is also the beginning of a new cosmic entity, one that will continue to influence its surroundings for billions of years to come. But what does this mean for the universe and for us? Could we ever experience the effects of a black hole collision firsthand? Could we survive a black hole collision? The universe is vast, and black hole mergers typically occur millions or billions of light years away, far beyond the reach of Earth. But what if such an event happened closer to home? Would we even notice, or would it spell disaster for our planet? The most immediate effect of a black hole collision is the gravitational waves it produces. However, even the most powerful of these waves become incredibly weak by the time they reach us. When LIGO detects a black hole merger, the actual space-time distortions measured are smaller than the width of a proton. This means that, under normal circumstances, a distant black hole collision poses no direct threat to Earth or the solar system. However, if a merger happened within our galaxy, things could get more interesting. The gravitational waves would be stronger, though still harmless to us. But if the collision resulted in the formation of an especially massive or fast-moving black hole, it could influence surrounding stars and planetary systems, potentially destabilizing nearby objects. The real danger would come if a black hole, newly formed or pre-existing, were to drift too close to our solar system. While black holes don't suck things in like a vacuum, their intense gravity could disrupt planetary orbits, leading to catastrophic consequences over time. Fortunately, the closest known black holes are thousands of light years away, and none pose an immediate threat. For now, black hole mergers remain spectacular cosmic events, reshaping galaxies and generating ripples in space-time. But from our vantage point, they are mostly silent, distant phenomena. Final thoughts. What black hole collisions reveal about the universe. Black hole collisions are some of the most extreme and awe-inspiring events in the cosmos. These titanic mergers not only create new, even more powerful black holes, but they also send gravitational waves rippling across space-time, giving us a direct way to study the hidden depths of the universe. Thanks to observatories like LIGO and Virgo, we now have the ability to listen to the universe in a completely new way. Every detection of a black hole merger expands our understanding of gravity, space, and time, confirming predictions made by Einstein over a century ago, and raising new questions about the nature of reality. These collisions also shape the evolution of galaxies, contributing to the growth of supermassive black holes that dominate galactic centers. Over billions of years, such mergers have played a crucial role in sculpting the universe as we see it today. While black hole mergers are incredibly violent, they are also safe from us, at least for now. The vast distances between stars and galaxies mean that Earth is unlikely to be affected by one of these cosmic events. But the more we study them, the more we may uncover hidden physics that could one day revolutionize our understanding of the universe. In the end, black hole collisions are not just massive astronomical events, they are gateways to knowledge, offering us glimpses into the most fundamental forces shaping existence itself. As technology advances, who knows what other cosmic secrets these events will help us unlock.